All right, if you were in Science League, you saw this. What we have is a heating curve here, which I know doesn't look too much like a curve, but if you were to kind of imagine this, this would be like if you took a bit of ice, so solid ice, and then you heated it up. Now, which sounds weird because ice is so cold, but you can have colder ice, you can have warmer ice, which is weird again, but as your ice cube warms up, eventually it'll get to a point where it starts to melt. So this would be all melting. All right, melting. And then once it's all melted, then instead of having ice, you have water, right? So here you have very cold water. And then as you heat it up, you get warmer and warmer, hot water. And then once it goes from here, liquid to gas, then over here you have boiling water. All right. And then once it all boils away, then it's all a gas. And then you would have a cooler gas, which might be 100 degrees. And then you might have a really hot gas, which could be maybe 200 degrees, all right? So let's take a look at what's actually changing here. So what's changing when you go from this point to this point here? Not the state, the actual temperature, because it's heating up here. So we're gonna put a delta T here for the temperature's changing for the solid. But notice when it actually starts to melt here, is the temperature changing? No, the temperature should stay the same if you mix it up. If you had like a drink that had some ice cubes in it, if you mix it up, that drink with your ice cubes and your water, that should stay at 0 degrees Celsius until all the ice cubes melt, all right? But the important thing with that is you have to mix it up, or it'll be warmer wherever the ice cubes are not. All right, so what's happening here, this is a change of state, all right? And then this liquid, this would be a change in what? Yep, temperature. Boiling, it's going from liquid to gas, so that's a change in state, good. And then the last one is a change in temperature, yeah. So delta S, what did the triangle mean? Change. Yeah, good, so that's change in state. And then delta T is a change in temperature. Okay. You could also have this as just like letters, so this would be S for solid. You could have S, so liquid, and then liquid. So you could use gas, or you could use V for vapor, all right? And then the last one would be vapor. I like to use the word vapor instead of gas because technically gas is at room temperature, it's a gas, all right? If you have to heat it up or change the pressure, then technically it's a vapor. But that's the only difference between those two. All right, so let's check this out. Let's see if we can answer question 7. It says, identify the point on the graph where each of the following occurs. So where does melting begin? C, good. Okay, and then freezing begins at? Oh, interesting. So we looked at this from one perspective, right? We looked at this from starting out as an ice cube and then heating up, right? But think about it the other way. All right, if it went the other way, it would start up at the top and then do something like that, right? Now, a lot of it would be the same. Like this would still be a vapor, this would still be liquid, this would still be solid. But instead, what's actually happening on this plateau? Yeah, it's going from a vapor to a liquid here, right? What would we call that when you go from a gas to a liquid or a vapor to a liquid? Yeah, this would be condensing. Yeah, exactly, or condensation. So we have condensing, all right? And then we have our liquid here. The liquid's hot, then it cools. And then what happens when the liquid goes from a liquid to a solid? What do we call that? Freezing, yeah, freezing. All right, so now we can answer this question a little bit better. Where does freezing begin? Yeah, D. Because here, if we're going backwards, it's liquid, and then it starts becoming solid here. So if it starts becoming solid, that means it's freezing. So the answer would be D for that one. Does that make sense? Yeah? Okay. And then C, where does boiling begin? E, good. And then condensation begins? Bless you. Yeah, it's going to be F because you have vapor, and then it's going to start condensing in this spot right here, which is F. Okay. Does the substance give off or take in heat as it goes from D to C? As it goes from D to C, so it's going that way, right? So it's not melting, it's going to be freezing. So what's happening when it's freezing? Is it giving off heat or is it taking in heat? Yeah, it's giving off heat. It's losing energy, right? That's why it's becoming a solid, all right? So this graph wasn't the best one to answer a lot of these questions. This one was, and then you can just flip it, all right? And the same thing's happening. So this one, you would have to add heat to it, right? And it says here, as we're going across, you're adding energy. And then this one would be the opposite. This would be losing energy. So that's why it becomes a solid at the end, all right? Any questions with that? Okay. All right, why does the temperature remain constant during a phase change from E to F? We're still putting energy into it. That didn't do anything. We're still putting energy into it, but the temperature's staying the same. What is that energy being used to do? What is it? Energy is being used to break the bonds between molecules. Or it's being used to break the IMF, or the intermolecular forces. So that, instead of raising the temperature, all that energy is being used to break the bonds in between the molecules instead of raise the temperature. All right. Same thing's true down here. When you're melting an ice cube, the temperature stays the same because all the extra energy you're putting into it is being used to melt that ice cube. All right. And then it says, explain what happens to volume as water temperature goes from 4 to 0 and then freezes. So when you go from 4 to 0, what's happening with the volume? 4 to 0 and then freezes. Ice cubes are less dense, right? That's why they float. So what's happening to the volume? It has to eventually what? Expand. All right, so the volume would expand. All right, so volume expands, density decreases, that's why ice cubes will float. All right. And what's happening there is the intermolecular forces, those hydrogen bonds between water molecules, when it's a liquid, they can actually be closer together, but then when it becomes a solid, they actually spread out a little, and that's why the volume increases, the density goes down, and it floats. Okay, any questions with that?